going to do it symbolically first. We got A point B times CD point EF. What's the rule?
Line with the decimals.
No, we got a line.
No, you don't have to line with
You
the
gotta
decimals.
the amount of digits after the point. You count how many.
Yeah, we're gonna multiply this through, right? We're gonna multiply it times F times E times C times D, right? And that's all gonna spread out down below. Then we're gonna come back here and we're gonna count the number of decimal places to the right for both terms. So over here it has one place.
Oh, right.
Over here it has two places to the right. We're gonna add those together, it's 3 places. So when we're done, we're gonna take our decimal and we're gonna move it 3 places to the left.
Right.
And that's gonna be our answer. Okay. Everybody follow me? We'll do a couple of examples also. I'll give you a second to get this down. All right, this probably isn't as clear cut as it should be. All right, multiply the decimals as normal until you get to the answer. Then count the number of digits to the right of the decimal for both numbers. That's the key part here. Then move your decimal in the answer to the left, the total number of digits to the right. So if you had 2 on the first digit and 2 on the second, the total is going to be 4. So you move your decimal 4 places to the left in your answer. All right, let's go back and let's count up the digits to the right of the decimal. This one has 1 place. This one here has 2 places. The total is 3 places. So I start here. I got to move it way over to here. Yeah, we have to add a 0. So add a 0 to it. That's your final answer. Okay, the crux here is to add these digits together, and that's the number of digits you move it to the left. Most students make the mistake is they only add 1. That's what I usually see. Make sure you take the digits to the right on both numbers. Okay. All right. So let's do this one. 710 times, what is this? 3 10,000s?
Yes.
A little practical application of this. All right. I think what Mariah was saying is we don't have to multiply the 710 by these digits here.
Yeah.
Right. If she said that, she was correct. So let's say 3 times 0 is 0, 3 times 1 is 3, 3 times 7 is 21. That's what we're going to get. Now we got to count the digits to the right of the decimal. Well, over here we don't have any, so that's simple. Over here we have 4, so it's 4 places. The decimal starts here. We got to move it 4 places to the left. It goes right there. We got to add a 0 to it, so it's 0, 2, 1, oops. 0, 2, 1, 3, and we could actually drop this 0 off because it doesn't add any value here. So let's multiply this out. This is going to be 4, this is going to be 6, this is going to be 18. There's only 1 place here, so we have to move the decimal 1 place to the left, so it goes right there. So we get 186.4.
Oh, so why did you drop the 0?
Because they don't add any value. If I did,
1.8.
there would be, if I started at 200, this would be 0, 0 here, and the answer would be the same.
And even if you're kind, then that's...
All right, let's do it with the zeros in it. Watch. All right, when I start out, I got to start here now. 0, 0. Now I'm going to get 4, 6, 18. Now I got 3 places, so my decimal starts here. I'm going to go to... It's the same thing.
You have 3 places or 4?
Well, here I had 3,
Okay.
so I went over 3.
Well, how about you? Oh.
You don't count that, yeah.
Yeah, that's a whole number. So I just saw this, since this doesn't add any value, I just said, well, let's truncate those and multiply it out like this.
But could you do that to the same with that 0003?
No, you can't do that
Okay.
to this or this number. As long as they're to the right of any 1 to 9 digit, yes. But when they're in front of a
Right.
1 to 9 digit, you cannot do
You
that.
cannot do that, okay.
Excuse me, how about the
Now we come to division. I'm going to take this problem, I'm going to do it twice. I'm going to say 23 to 123.0. Here's what I'm going to say. If there's no decimal in your divisor, all you have to do is project your decimal point
Right.
up. Then you divide as normal. Okay? Let's do the other scenario. Now we got 20, it's 2.3 into 123.0. In this case, we have a decimal point in our divisor. Technically, when we're dividing, we can't have a decimal point in here, so we got to move this one place to the right. If we do it to our divisor, we also have to do it to our dividend, so then it moves over to here, and then we project it up. So if you have a decimal point in your divisor, you have to move the decimal point so the divisor becomes a whole number, then make that same decimal move in your dividend prior to projecting your decimal point into your quotient. Does that make sense? All right, let's see if the definition works. If the divisor doesn't have a projected decimal point in the dividend directly up into the quotient. So what they're saying is, the divisor doesn't have a decimal point, so in the dividend here, just project this point directly up into the quotient. In this case, it's saying if there's a decimal point in the divisor, we have to move this decimal point so it becomes a whole number. So in this case, we have to move this to there. If we do it to the divisor, we also have to do it to the dividend, so we also have to move this to here and then project it up into the quotient. Okay. Now I know it's wordy and there's a lot of terms here, but if you have to put it into your own terms, that's acceptable. Let's do this twice. Let's go 23 goes into 123.0. In this case, there's no decimal here, just project this up. 23 doesn't go into 12, does it? I mean 1 doesn't go into 12. How many times is it going to go into 123? 5 times? Alright, so we got 115. We subtract that away and we get 8. Let's bring down the next 0. 8 is smaller than 23, so that number's good. 23 goes into 80. 3 times, so we'll put a 3 here. This will be 9. This will be 69. This will be 11. 11 is less than 23, so this number is good. Let's add another 0. Bring it down again. Well, we had 115 here with 5. This is 110, so this has to be what? 4. So this is 12, 1, 8, 9. This becomes 18. All right. So now we've got to add another 0. 18 is less than 23. The 4 is good. Now we have 180. 23. 161.
Yeah.
Let's subtract that away. 19. 19 is less than 23. I guess we could bring down another 0. 190.
It's 8,
It's
Like
8.
zeros.
so it's 184.
184.
Does this have to end?
This is
Never
6.
gonna
6
end.
is less than. Let's end there, all right?
Okay. That's
We
it.
got 4. That's
I
enough.
left it there, so.
You left it there? All
3
right.
places, or 4 places.
I mean, technically, we're supposed to keep going,
Right.
Yeah.
but just for instructional purposes, we'll stop. All
Okay, so on your test, if we have something like this, keep going.
right, let's just change this. We'll take the same problem. We're going to make it 2.3, and it's going to go into 123 point. All right, now in this one, we got to move the decimal place to the right. We have to do the same thing here. So let's move this one place to the right. So the decimal point becomes right there. We're going to project it right up to there. Let's see what changes are made.
Be 53.478.
All right, you're right. That's the only thing
Okay.
that changed. For clarity, I'm just going to take
Yeah.
this out. Okay, we've made that move. All right, so 23 doesn't go to 1, 23 doesn't go into 12. 23 goes into 123 how many times?
5.5.
So we put the 5 directly over the 3. This is going to be 115. We're going to subtract it away. We're going to get 8. We're going to drop down to 0. We're going to get 80. How many times? So we put a 3 here. We're going to get a 69 here. We're going to get 11 here. We're going to add another 0. We're going to drop it down. We got 110.
And that's gonna go after the decimal point, right?
Yeah, now it's going to be what? 4, 7, 8. So the numbers are the same, just the decimal point changed the value of your answer. Now, let's see, does it make sense? This one originally was 2.3 into 123.0, right? That's what we were dividing.
Yeah.
Does it make sense that 2.3 goes into 123 more times than 23 goes into 123?
Yeah.
So it does follow some logic.